Bismillah Rahman Rahim. Welcome to my channel Learn Math with Sayyid Ali. So here is some more examples asked by some of the students in grade 11. Trigonometric identities solution. And we know that the tips to solve the trigonometric identities, you have to know your identities, which we did in lecture 1 and 2. Start with complicated side, the big side, right, which is difficult side. So if you go through the complicated side, then you resolve it into the other side, which is simpler. Sometimes you have to focus on other side too, because sometimes you stuck on the right hand side or left hand side and you cannot get anywhere close. So you have to simultaneously solve right side and left side to prove that the two identities are equal. So that is the most complicated situation where you have to keep an eye on the other side of the equation as well, right? So you have the tips. You have to know your identities. You have to start with complicated side, convert functions to sine and cos, and then you must be practicing. So here is question 1, which was asked by one of my students. Cot square theta is equals to cos square theta, cot theta, cos theta whole square. So this is the question. Which side we will take? We will take right side. It's more complicated, and we can see that there is a whole square which will help us. So cos square is outside the bracket. We remain with it and try to solve the bracket. Oh, there was a plus in between in the question. So now what we can do? So we can write cot this square. That means we can write this bracket 2 times, right? Cot theta cos theta times cot theta cos theta. This is what the first thing comes to mind, that there is a whole square, so we can write it 2 times. So still we have cos square theta outside, and we have lot of activities here. So cot and cot, that means I can write cot square theta, right? And cos square theta. I can write like this, cos square theta, right? And then I can break cot square theta, because I know that cot is cos over sine, cos square theta over sine square theta, and we have cos square theta here, right? What we are seeing is that we can have cos square theta makes it cos power 4 theta divided by sine square theta, and then we have to add these, taking LCM of sine square theta. You have to be very good at LCM and addition of the fraction. You divide with this sine square theta goes, we multiply with the numerator, so cos square theta times sine square theta is your first thing, plus when you divide this you get 1, and you have the numerator only, which is cos power 4 theta. Then you can say that cos square theta is common between the two, so cos square theta is common. What I am left with inside the bracket is sine square theta plus cos square theta, because it was 4, right, power 4. So I have cos square theta divided by sine square theta. Now we know the identity that sine square theta plus cos square theta is 1. So I can write cos square theta times 1 divided by sine square theta. And we know that cos theta over sine theta is cot theta. So I can say this is cot square theta, which is my cot square theta here. So that is proved that left side is equals to right side, and we say identities have been proved. So you know how we take one side which is more complicated and start doing it, and using those LCMs and trigonometric identities, we can solve the equation easily. So this was the first question, and the second question in this exercise sent by the student is, let's see what the second question. So second question here I have sec theta or sec x, whatever angle is, sec x minus cos x is equals to sin x dot tan x. Which side will you take? Okay, I will try left side. So sec is secant theta is 1 over cos x minus cos x. And what I have to do now? Now I have to take the LCM, right? So what is my LCM? Cos x is my LCM. When you divide, you get 1. 1 is 1. Minus, when you divide cos x, when you multiply the numerator, which is cos square x. And 1 minus cos square x, you know, is equals to sin square x divided by cos x. So sin square x, I can write sin x over cos x, right? And another sin x, right? So sin over cos x is tangent. So tangent x dot sin x, which is my right side. Sin x, tan x, right? Is the same. So left side is equals to right side. And we prove this identity, proved. So we start with left hand side, and we know the identities, and therefore we apply the division rule, right? The how to take the division of the fractions, and then we come up with the sin square x over cos x. We break it and then we equate it to the desired result. So we have to keep an eye on the right side as well while solving the left hand side. There is another question in this regards, and this might be the last question because I don't have more questions on this from the students. If I have, I will make another video. So the question number 3 is, cot theta plus 1 is equals to cosecant theta cos theta plus sin theta. This one is tricky because if you start with this, maybe you can stuck somewhere. So I will start with the right hand side, which is easier, and I can see that it can be transformed into that. Cosecant is 1 over sin theta cos theta plus sin theta. So now what you can do is you can write down separately cos theta over sin theta plus sin theta over sin theta, and you can say that cos over sin is tangent, so tangent theta plus, and this is cancelled, so this is 1. So this is my cot theta, or this is my cot theta. Cos over sin is cot, sin over cos is tangent, so my mistake. Cot theta plus 1. So this is my left side is equals to right side, proved. Right? Similarly, one more example I have in this regards. Hope you understand this, right? So I did it quickly because I have another one and I have to complete it like this class quickly. So the other question, question number 4 is tangent square x 1 plus cotangent cot square x is equals to 1 over 1 minus sin square x, right? So I will take left side because it is more complicated. So what I will write, tan square, so I will multiply, real multiplication. So tangent square x plus tangent square x and cot square x. This is what I can write, right? So I multiply this because it was outside the bracket. So I say, okay, tan square x plus tan square x dot cot square x. Now I can replace the values here because here is the multiplication and I can cancel maybe something. So sin square x over cos square x is your tan square, and cot square x is cos square x divided by sin square x. So you are in a good position. Cos square x cancel, sin square x cancel, right? So you are left with tan square x plus 1. So tan is sin square over cos square x plus 1. Now we have to keep an eye on the right side. So now we have to take the LCM because it has an LCM of cos square x, right? If you take the LCM cos square x, then this is gone and I have sin square x plus 1, right? So 1 divided by cos square x, so cos square x. So what I have? Sin square x plus cos square x. Now I am very close to get my right side. So that is 1. So 1 divided by cos square x, right? And 1 over, you know the identity, I will explain here. Sin square x plus cos square x is equals to 1, right? So what is cos square x is equals to? Cos square x is equals to 1 minus sin square x. So that means instead of cos square x, I can write 1 minus 1 over 1 minus sin square x, and which is my right side, 1 minus sin square x. So that means I proved my identity, proved. Left hand side is equals to right hand side. Hope you understand. I did it quickly, but you have to take a breath, check your identities, revise your identities, start with complicated side and continue doing it until you get the other side of the equation. So hope you like the video. If you like it, subscribe to my channel, press the bell icon button to get the more knowledgeable, more practicable videos. This was for grade 11. So thank you for watching.